Okay, thank you everyone for joining us. I appreciate you guys taking the time. I know for a lot of you it may be lunchtime. It is for me, at least here on the West Coast. So thank you very much for taking the time to join. We will take all the questions kind of at the end. So if you have some questions, go ahead and put them into the questions window and Stuart will kind of collect those, kind of group them by topic, and then we'll answer them all at the end. Quick background on LA Networks for those who might not know us. We've been a Cisco Gold partner for over 20 years in the LA market, and I've been with them almost since the beginning. My background is primarily in traditional route switch networks. I expanded into doing a lot of data center networks, and then maybe about 3.5 years ago, I started working with AWS networks. And I've been doing that quite a bit for the last 3.5 years. We're not going to go in depth into AWS in general. We're really going to focus on the networking components. We will have an overview of some of the common structural things that you have to talk about, things like regions and availability zones. We really can't have much of a conversation about networking without at least including some of those terms. So we'll have some of those overviews. But then we're really going to focus on the networking constructs, and it will be an introductory style presentation, so we won't go super in depth or do any configurations or demos. Those things we can definitely work on if you do have interest later on for sure. So with that said, we will go ahead and get started. So just a quick overview on the agenda. Like I said, we'll cover some of the AWS common items, and then we'll go into networking basics. Then we'll talk about the specifics of network connectivity, so IGWs, BGWs, items like that. And that will actually be the bulk of the slides, is those two components. And then we will go into briefly some new developments. These are features that were maybe enabled in the last year or so. A lot of them maybe much more recently, like say reInvent 2018. Which was just last November. So some of them are very new. And then we'll wrap up with some kind of tips and tricks and recommendations, on when you're working with AWS and things to keep in mind. And then at the very end, I do have several links. So that'll include things if you do want to go more in depth. If you really want to, maybe you want to go get AWS certified, I have some links for a couple of great training resources out there. Maybe you really want to learn more about transit VPC or TGW or something like that, things we'll all talk about. But you really want to go more in depth in this kind of introductory talk. I have links for those sorts of items as well at the end. The very first common item we'll kind of talk about is regions. And when we talk about regions, we're really talking about just kind of dispersed global areas around the world. Right? So a region might be, for example, US West 2, which is in Oregon, and another region might be in Sao Paulo, Brazil. Another one might be in Sydney, Australia. But they're large geographic footprints for the AWS backbone and network. And this is probably a little outdated from the recent reInvent conference. I think that there may have been one or two more regions that were launched since then. So each of these circles does represent an Amazon or AWS region. I just may be missing a circle here or there. Likewise, the little numbers in those circles are what we call availability zones. And an availability zone is contained within a region. So again, using US West 2 or Oregon as an example of a region, the availability zones you could kind of think of as a highly independent infrastructure cluster, or what I would call a building or a data center, like a colo, right? It's not a colo per se, it's dedicated to Amazon for the most part, probably exclusively in almost every region. And so the availability zones are really separate buildings, and they're highly independent of one another, right? So these days, the Amazon practice is to always have a minimum of 3 availability zones in any given region. Some regions have more, and some regions do have less, The ones that have less than 3 are older regions that maybe were stood up before Amazon kind of came up with the 3 availability zone model. And a couple things to keep in mind when you're working with availability zones is that they are highly independent. They're completely separate facilities. So there can be a little bit of latency between them. I'm not talking a lot of latency. You're not going across the country or anything like that. But for example, in Oregon, I've noticed just in my own work with different clients and so forth, sometimes the availability zones, within that region might be, 1 or 2 milliseconds apart, and sometimes the other availability zone might be, 3 or 4 milliseconds away. So they're clearly not just across the street from one another. There's obviously more significant, distance between them than just that, right? So just kind of keep that in mind. That also means that our availability zones are kind of hard layer 3 boundaries, just so you know, right? And we'll talk more about this when we get into some of the networking specifics of center blocks and subnets. You don't have the ability to really easily span a layer 2 domain across availability zones. You don't have it at all within Amazon. There might be third-party marketplace type products that might allow you to do that, but you cannot do it within Amazon native infrastructure. So these are hard layer 3 boundaries. They have separate powers, separate cooling, so that an outage in one availability zone should not have any impact on the other availability zones within that region. I say should because anything is possible. If we took, for example, California as an example, we could have some kind of a seismic event that might take down all the Silicon Valley availability zones at once, potentially, right? So there could be certain disasters that might be more impactful, but in general, the availability zones are highly independent of one another and highly resilient when taken as a whole. That doesn't mean that any one given AZ is going to be completely up all the time. They will have maintenances, they will have outages, but it shouldn't usually span multiple availability zones. So now we'll talk about the next most common item, which is what most people are, well, maybe not anymore, but at least in the early days, most people were worried about what we call EC2s. That stands for Elastic Compute Cloud, which to me is not a natural way to think of it. I would have thought cloud compute, but EC2 just stands for Elastic Compute Cloud, and everyone just calls it EC2, so you might as well call it that also. And it's kind of the fundamental unit or the base unit of computing within Amazon. And just so you're aware, a lot of the things that we will talk about today and a lot of things that we'll never touch on today are really EC2s under the hood, right? So when we get into talking about different routing services, you'll find that what they really are EC2s that Amazon has used or they've leveraged to provide some kind of service to you, right? So when I say that the EC2 is kind of a fundamental unit within Amazon, it's really fundamental, right? There are exceptions for sure, but a lot of things will run EC2 under the covers. So real quick, when it comes to EC2, there's 4 main ways that companies might, acquire these or utilize these, right? They could go on demand, which just means you pick the server that you want and then you pay by the hour with no commitment. So that can be the most expensive. You can do things on the cheap. I use on-demand instances all the time that don't cost me anything because I'm using what they call micro instances. And as long as I don't exceed certain thresholds when I use them, they don't charge me at all, which is pretty convenient. So, however, if you were going to try and run, some intense application in an on-demand fashion, you might find that the bill is going to tick up, really fast for you. There are reserved instances, and this is where you might pick the type of server you want, what we call the instance type that you want. And then you're going to pick a commitment term, like it might be 1 to 3 years, and how you're going to pay, maybe all up front or something like that. And these reserved instances have recently gotten a little more flexible, I believe, on some of these terms. But in general, the idea of a reserved instance is since you're willing to commit to Amazon that you're going to need a certain amount of compute over a certain length of time, they're going to give you a price break, right? So if you have an app that you know needs to be dependently available to your clients or customers, a reserved instance can save you a lot of money over an on-demand instance, particularly as you start to scale up the instance type. And then there's spot instances. I tend to think of those as eBay for compute cycles. I don't know that that's really the best way to think of it, but it is how I think of it. These are effectively instances that you basically bid what you're willing to pay for, and then you're allowed to have those instances as long as the price doesn't fluctuate. So Amazon, of course, will have lots of spare CPU cycles at any given time, particularly, say, off hours within a particular region. So up in Oregon, just picking on Oregon today, up in Oregon, maybe between 10 p.m. and 4 a.m. It's not a lot going on, and so you may find that the per hour charge for your spot or for instances starts to lower. So you can buy those as spot instances. These are really good when you have perhaps large workloads that need to get run, but those workloads are also flexible because the prices will eventually go up and you'll lose your spot instances. So it's really application driven, but Amazon has found, my understanding at least is, and I don't do a lot on the compute side, but you kind of need to know about the EC2 background. But my understanding is that this has been a good differentiator for them, these spot instances. If they've got spare cycles to sell, they might as well sell them at a bargain as long as they can reclaim them when they actually need them, right? When prices start to go back up, when demand starts to go back up. And then there are dedicated hosts. This is if you truly want some dedicated hardware so that you can avoid things like multi-tenancy. All of these EC2s, just to be clear, are typically, not always, but typically they're running in a hypervisor sort of environment. So they're the equivalent of virtual machines, right? So you can get dedicated hosts, which allow you to grab some dedicated hardware so that you don't have to run, in a multi-tenant situation across a hypervisor, right? So my understanding is that can help with some licensing. I don't know if this Oracle one is still accurate or not. When I first put this together, I should probably validate that again. When I first put this together, that was one of the use cases I'd heard. I don't know if it still is usable or not, but in general, you could do dedicated hosts. I haven't really run into anyone that does those, but it is possible. Next common item we need to kind of consider is IAM, which just stands for Identity Access Management. This is actually a global service. So we talked about the concept of regions and we talked about availability zones. Some resources and services are region specific or perhaps even availability zone specific, and others are global. And IAM, or your Identity Access Management, is one of those global services. It's not tied to a region. You set this up globally, and it defines how your organization globally will access and consume Amazon resources, right? So I'm not an IAM expert. I don't want to pretend that I am, but this is kind of a networking centric talk. So I will say if come from a networking background, this is a very similar approach to, say, RBAC in ACS or in ICE these days. So the concept of having users and roles and combining those to get granular permissions that you can inherit on an account. Just be aware that when you do set up IAM, you need to be very careful that you're not giving people more permission than they need. You also need to be certain that, like for example, if you give them console access, that you get them a password, otherwise they won't be able to log in. So there are some tricks that maybe fall in on IAM. I think it's fairly well documented. So, but that's always your first step. Your first step is you have to create an account. When you create that account, it's going to usually dump you right immediately into IAM so you can set some users and roles and permissions and so forth. And you can get really granular, or if it's maybe just for you to play around in a sandbox, you don't have to get granular at all. Maybe you just need an admin account. So there's a lot of flexibility there. So with that, we'll kind of now break into the networking basics. So just like I mentioned, that EC2 is kind of the fundamental component for computing. The VPC, or virtual private cloud, is the fundamental unit for networking. So we'll spend a little time talking about the VPC. It is the base building block for all network services that you're going to deploy in Amazon, or at least most services you're going to deploy in Amazon. We'll talk about at least one exception towards the end with new announcements. This is probably not as accurate a statement as it used to be, but it's a little accurate still, which is the VPC can be kind of thought about as meaning your company or your organization's specific data center in the cloud. It is self-contained by default. So when they say private cloud, virtual private cloud, they truly mean private, meaning if you do not do anything to allow traffic in or out of a VPC, then traffic will not go in or out of a VPC. It is private unto the things that are in that VPC, right? Usually we want some kind of traffic getting in and out of our VPC so that we can go in and administer, the instances that we're spinning up, or maybe, I have a web front end or something I need people to hit from the internet. So we usually do want to talk about having access in, and we will for sure. But by default, if you don't do anything, then it is truly private. Where that analogy breaks down is when we talk about a data center in terms of legacy or on-prem data centers. Usually those are big buildings which might have, racks or many racks or large cages of racks. The VPC could be maybe not as big or as small as you want to make it, but there's a lot of flexibility, and you could get quite small in a VPC. I think you can go down to about a /27, which is 32 IPs, and I think 5 of those end up getting reserved, obviously, for network and broadcast and default gateways and so forth. So you would never build a data center that was kind of predicated on a /27. So the analogy is not perfect, but it still holds by and large. One important thing to realize is that the VPC is a region-based construct, right? And it is tied to your IAM, or your identity access management, right? So when you create your account, one of the things that Amazon does is it goes and it creates a VPC in every one of the regions for your account. So typically speaking, one account could have many VPCs. However, a VPC can only be tied to one account. So accounts to VPCs might be one to many, but VPCs to accounts could be many to one, right? There are exceptions to that in some of the newer announcements that just came out of the reInvent conference. They have the concept of the shared VPC. But for the most part, just keep that in mind. So when we say that a VPC is a region-based construct, that means if I have an app that is in Oregon and it has another instance in, let's say, Northern Virginia, they're not in the same VPC. They're not in the same subnet. They don't have the same resources. I can build them out to look like they have similar resources, but that's going to take some architecting on my part, right? Or your part, or whoever's doing that work's part. So the VPC is regional. Now this is not true for necessarily all cloud vendors, but we are kind of focused on AWS today. So just be aware that your VPC is a region-based construct. It doesn't span multiple regions. And if you want VPCs to talk or communicate in any way, shape, or form across regions, you're going to have to architect that communication, right? We'll touch on that a little bit, but that can take us down a rabbit hole, so we'll stay high level. And then there is, as I mentioned, when you create your account, they will create a default VPC with a default CIDR block in every region. And I believe it's still a best practice that you really should not use or try to delete that default VPC. My understanding is you can no longer delete it. You used to be able to delete it, and it would lead to problems. So again, to talk about a networking analogy, the way it was explained to me by an Amazon networking person was, think of the default VPC as you might think of VLAN 1 on switches. It's there, it needs to be there, you're not going to get rid of it. However, you really shouldn't put a lot of production traffic or any production traffic really in it, right? So usually the first thing that you're going to want to do when you're working with VPCs is spin up a new VPC that is non-default and start working with that. Again, if you're doing something in a sandbox that's fairly isolated or something that you're going to spin up and play around with to test something or learn on and then get rid of, it'd probably be fine to use the default VPC. But if you're talking about architecting some kind of a cloud strategy for a company, you probably want to think a little more deeply about that and not just use the common, right? So one thing that happens is that the VPC, when you create it, you need to have a CIDR block, okay? So as I mentioned, I think it can be as small as a /27 or as big as a /16. You can add secondary CIDR blocks. That was not always supported, but it's, I think, been out for over a year now. So you can add secondary CIDR blocks. I think you can go up to as high as 16/16s for your CIDR block. So that's an awful lot of addressing. So you have a lot of flexibility there. And then that CIDR block contains these sub-objects called subnets, and they are exactly what they sound like if you have a networking background, right? So we have our CIDR block, and then we break that into, we VLSM it, variable length subnet mask it into multiple subnets. You do the exact same thing in your VPC. You have your CIDR block, and then you break that down into subnets. The subnets need to belong or be included in the CIDR block's summary range, right? I can't have a CIDR block of 10.1.0.0/16 and try to create a subnet object of 172.16.1.0/24. It has to be common to whatever my CIDR block is. As I said, you could have multiple CIDR blocks, so you can expand that. You're not fixed on that. So you do have a little bit of flexibility there. Just keep that in mind. The subnet object is actually tied to an availability zone. Right, so remember I said that there was a layer 3 boundary between those availability zones by default, and here it is exactly right in front of us right now, which is that when I create a subnet object, that subnet object has to get tied to an availability zone. I cannot tie a subnet in any way that I'm aware of to multiple availability zones. You pick one, right? I put it in AZA or AZD or wherever it would be appropriate, right? So one good practice, you want to be sure that you create your CIDR blocks large enough that you can subnet them the way that you feel you need to, right? And lastly, there is a VPC router. There is a router like a default gateway, but you do have very little ability to interact with it, and you should not think of it in the same way you might think of a Cisco router. We'll talk a little more about that. So here's what it kind of looks like. I've got my VPC. You can see I have my CIDR block. In this case, it's 172.16.0.0/23. I have subnet 172.16.0.0/24 in AZA, and I have 172.16.1.0/24 in AZB. And then you kind of see there's this little invisible or semi-visible router in the middle. That's my VPC router. And the VPC router, you can do things, for example, like programming in static routes, right? But what you can't do is you cannot log into it and run commands. You can't say like, hey, show me the state of this, or show me your ARP table. I can't log into it and change an IP address. One thing I haven't really touched on here is that the availability zones, those subnet objects, are usually enabled for DHCP, and they auto-assign the router interface to the VPC router as the default gateway. You can probably overwrite that if you had a need to, but in my experience, most people don't. So you cannot really easily interact directly with the router. I can't SSH into a VPC router and run any show commands like we would with a Cisco router. So you don't want to think of it in that same way. When it comes to these subnets, the subnets are by default attached into the router. You do have the ability to detach a subnet, but what you do not have the ability to do is take the CIDR block out of the VPC router table. The CIDR block itself will always be in the routing table. It's not really flexible or removable. But I could detach a subnet so that even though I might send out a summary, you might not be able to route to a specific subnet or not reach a specific subnet. Your route might get there, but you might not get there once you're in the VPC object. Let's talk a little bit about security objects. So when we're talking about network security objects, we're really going to talk about two items at the VPC level. One is NACLs or network ACLs, and the other one is security groups. And while they're similar, they do have some important differences. The NACLs are very similar to a normal Cisco ACL. You're familiar with those, right? So I can write rules that are permit or deny, for example. A NACL is written against a subnet object. I basically can say, hey, here's the traffic I want in or out of my subnet. Like a normal ACL, they're not stateful. They don't do any stateful inspection or pay attention to three-way handshakes or anything like that. Obviously, there's some flexibility on the Cisco side with that. There is no flexibility with that on the Amazon side. So the network ACL is there to protect what goes in or out of a subnet. There is a network ACL that's by default generated that's a permit all. So by default, all traffic's allowed in and out of a subnet. But remember that a VPC by default has no connectivity to anything other than itself. So while there is a default permit any, it really doesn't allow anything other than your hosts to talk to each other within the VPC. Security groups are a little bit different. They are similar though. They have a syntax that looks a little similar to an ACL, but these are a little more like a firewall in that they are stateful. Okay, so these you don't have to write return rules for. They will pay attention to the state of a session, and that's a nice benefit. You don't have to write a rule for, say, return traffic. However, unlike the network ACL that's written against the subnet object, these are actually, I tend to think of them, this might not be the best way, but I tend to think of them as containers. Security groups are containers of rules, and you place objects or resources or instances into a security group, and they inherit all the rules in the security group. Okay? Now, security groups you can only write permit rules against. They have an implicit deny all at the end, just like an ACL or a firewall will have a implicit deny all. So you can only write permits. Everything else will be denied. If it's not explicitly permitted, it's implicitly denied. Be aware of that. You can put an object into more than one security group, but because they're all permit statements, those security groups are, the rules are additive, right? So it doesn't look and say like, I'm going to take the most restrictive. It says, I'm going to add all these rules together to a least restrictive policy. So when you start nesting security groups, you need to be a little bit careful, right? Now, security groups, because they're tied to an actual object, like an EC2 instance, for example, they could block hosts that are in the same subnet or AZ from even being able to talk to each other. So you need to be aware of that, right? I could have two hosts that are next to each other in the same AZ, logically next to each other. Physically, they might not be. But they're logically next to each other in the same subnet, same VPC router, and they may not be able to talk to each other if you have a security group that would be blocking that access. So just keep that in mind. So let's take a look at this. So I have my VPC, I have my subnets, I put some hosts in those subnets. The first thing I might do is I might write a network ACL, and you can see that front ends those subnets. That's kind of defining policies as to what's allowed in and out of a subnet. And then I might create a security group, but you see that's applied within the subnet because it's really applied to the instance. Again, from my own personal way of looking at it is I think of the security group as a container of security rules, and I place objects into that container, and they inherit the rules that are attached in that security group. So last thing on networking basics here would be a quick word on routing, because we're about to get to a lot of the routing constructs. I would caution you against thinking of routers in AWS as actually routers. I tend to think of them as routing services, meaning think of it as maybe like a Linux box that has some routing capability turned on. Do not think of it as a Cisco iOS router with all the good and ill that might come with that Cisco iOS router, it's going to be a lot more stripped down than that. And remember that I mentioned this earlier, it's probably under the hood an EC2 or more likely a cluster of EC2s, which have some kind of routing capabilities turned on, right? One of the nice things is when they cluster them, they tend to have a lot of redundancy built in. They have things like multi-AZ capabilities built in. However, you may find that they have very poor performance and feature support compared to what you're used to as a normal router. So a good example would be when we talked about the VPC router, and this applies also to something called the VGW we're about to talk about. You get an exact maximum of 100 routes. Well, no one would ever think of creating a router that can only hold 100 routes. It's not a very useful router, right? When I started my career 25 years ago, even on a 2500 router back then with only 4 or 8 megs of RAM, I could still get over 1,000 routes, and that was back in the mid 90s. So to think that here in the almost 2020 we're only limited to 100 routes on a VPC router or a VGW, that sounds odd to a network person, but it is the case nonetheless. You might run into scalability limits in terms of throughput. For example, on the VGW, you get a maximum of 1.25 gigs of encrypted throughput. So VGW will usually terminate a lot of VPNs. 1.25 gigs, that's not insignificant, but you can buy an ISR these days that has more encrypted throughput than that, for example. So you can buy an ASR that has orders of magnitude more throughput than that encrypted. So now we'll get into some of the connectivity options. The first one we'll talk about is the VGW. Stands for Private Virtual Gateway. So I tend to hate the acronym VGW. I would have thought PVG made more sense, but I don't get a say in these things. So when you hear VGW, think Private Virtual Gateway. That private really means the VGW is used for connecting to your on-prem environment. It will terminate things like VPNs into your VPC from maybe your on-prem firewall or an on-prem router or anything like that. We're really talking about LAN-to-LAN type VPNs, not remote access VPNs. We're talking about something that's more permanent, right? So one thing to keep in mind with the VGWs, when you're creating VGWs, if you're going to build out VPNs that go to that VGW, which is probably the most common way people administer their VPC, is probably through a VPN that terminates onto a VGW. It doesn't necessarily have to be the only way, but in my experience, that's probably the most common way. Whatever your gear is that terminates that VPN, that's considered what Amazon calls a customer gateway or a CGW, right? So typically a CGW, we might think of it as an on-prem piece of gear like a ASA firewall or a Cisco ISR router or something like that. But it doesn't have to be. A customer gateway really is any layer 3 capable device that's going to connect into your VGW, but it is not administered by Amazon, right? So even if you had a virtual Cisco router up in Amazon that you were going to connect to other VGWs, then that virtual Cisco router would itself be defined as a CGW. So just something to keep in mind. So when you do build VPNs, which again are very, very common to your VGW, Amazon actually has a pretty good tool which will build the VPN configuration for you based on your gear. I think they probably have about 15 or 20 different vendors in there now. For Cisco, you could download a pre-built configuration for an ASA, an ISR, an ASR, and then you can also buy one that is more programmatic in nature. So you have 4 different options just for the Cisco as a vendor. It's probably one of the bigger ones. These VPN configurations that you can download are actually quite good. I'd say they're probably 95% accurate. There may be a few things, you want to read through the file. They'll have a lot of comments about what the different sections do. But you'll find in general, they're very good configurations that they automatically generate for you. I wouldn't just copy and paste everything that you get in that download blindly into your router or firewall. I'd read through it, but you'll find that it will be small specific tweaks, right? They might not know some specifics about IP addressing or something like that. One thing to be aware of, and we run into this all the time, VPNs in AWS on those VGWs, they have very aggressive timeout values. So using something like an IPSLA policy to keep the tunnel up might be a good idea. If you're actually not going to do VPNs, but instead use a dedicated circuit between you and Amazon, that's called a direct connect circuit or a DX, then you don't need to worry about that because you don't have to necessarily run VPN on top of it. I can actually directly connect my data center into Amazon's cloud through a DX. We're not going to cover direct connects in these slides. I don't see that as commonly, but if you're going to do a lot of your development in AWS, then direct connect's a good service for you to be looking at as opposed to VPNs. You'll just find that they're more scalable. When you talk about routing, the VGW only supports BGP and static. You really cannot log into the VGW directly at all, okay? So I cannot log into the VGW, for example, and see, hey, what routes are you receiving? What routes are you sending? I can't see things like what's, what's the status of my neighbor relationship in BGP or anything like that. You can dump the VGW learn dynamic routes by BGP into the VPC router. It's not enabled by default, but you can turn that on. It's called route propagation. It's a weird name. If you're a traditional network engineer, we wouldn't think of route propagation as kind of making visible one router's routes onto another router, but that's what it means in terms of VGWs. Be aware that the IPsec profile on the VGW is fairly old and dated. It still runs, for example, IPv1 only. You cannot do IPv2. So there's not a lot of room for change there. Here's what it looks like. I create my VPC, I create my CIDR blocks, my subnets. Now I add in my VGW, and I build out, I go into my VPC, I create my customer gateway, it represents in this case my ASA, and I build out my tunnels, right? And they just auto connect down to, I download my configuration and configure my firewall, but everything will be pre-configured for you on the VGW. You just need to go through this, kind of question and answer when you create the VPN object. An IGW is very similar to a VGW, but it's for public facing. So it's when I want to get to and from Amazon's internet backbone. So very similarly, I create my VPC, I create my CIDR and my subnets. Now I create an IGW. With the IGW, I'm going to need some form of NAT. We won't go into NAT in depth here, but you will need some form of NAT, obviously, if I'm going to go out to the internet backbone. I cannot do that with a 172.16 address. That's not going to get me very far. So, and it's also important to note that you could default route all your traffic directly to the internet, right through that IGW. Likewise, you could have specific host routes so that you can bring all your internet back to on-prem through your VGW if you wanted to. Putting in an IGW does not imply that you have to do a default internet route from your VPC. You could do specific routes. So kind of putting that all together, what does this look like, right? Well, I have my VPC, I have my CIDR blocks, I have my subnets, I maybe attach some NACLs to my subnets, I put in a host, I might secure that host further with a security group. I create a VGW, he connects down to my ASA on-prem with a VPN, I put in my IGW with some kind of a NAT object, and he gets out to the internet. And this kind of is what your basic VPC or Amazon network is going to look like. Now, there's a whole lot of details that you could go into, right? This is, again, kind of high-level introductory, but you need to think about things like, do I want a few VPCs? Do I want one VPC? Do I want a lot of VPCs, right? And there's a lot of reasons you could go back and forth on how to kind of determine that. It's a little bit out of scope, but this gives you a feel for the most common things you're going to do. This doesn't necessarily mean this is every single option or permutation. It's absolutely not, right? This gets you a feel for what it generally looks like. Real quick, and then we'll be wrapping up soon. Some new developments. There is something called the transit gateway. This is really big. If you're going to do a lot of VPCs, this can be really big because this might sound counterintuitive again, but remember this is more of a routing service than a router. Amazon VPCs don't allow transitive routing, meaning if I have VPC A connected to VPC B, and VPC connected to VPC C, I cannot get from A to C through B, right? I would have to build connections from A to C. And that's not a very scalable model if you're going to have a lot of VPCs. If you just had a few VPCs, it's absolutely fine, but it doesn't scale out very well. And so we used to do something called transit VPC routing. I have a whole talk from Cisco Live. If you'd like to learn more about that, you can reach out and I'd be happy to share that with you. But these days, that kind of gets replaced with something called the transit gateway, which does allow for transitive routing between VPCs through a third party, or not a third party, a new Amazon object called the transit gateway. And I have a link at the end. Shared VPCs, I mentioned this kind of early on. You do now have the ability to put more than one account into a VPC and share some resources. That allows for some efficiencies that might get missed or overlooked when we talk about the one VPC gets exactly one account in the old days, right? Private endpoints, these are very important because they allow you to do things like instead of having to put in an IGW to maybe get to your S3 bucket for some objects that you're storing, instead you can make that appear as a private endpoint within your VPC and then kind of tunnel that traffic back to AWS without having to get into the complexity of internet gateway and NAT objects and all those sorts of things. Cloud automated operations. I don't know a lot about this, but this was there were a lot of announcements at reInvent for this, where people are doing things like using lambdas, which are kind of serverless config scripts, or scripts I should call them, config scripts that might be able to run and automate a lot of things. They can automate things like checking to make sure that I don't have things improperly done or something like that. And last one is guard duty. So security is always a big concern in public clouds, and guard duty is kind of like an IPS for all your VPCs with a SIM kind of rolled into one, but not quite either of those. But it's an enhanced security option. And of course, you could fill this slide with dozens, if not hundreds, of bullet points of great, neat things. But these are some of the ones that kind of were a little bit newer. Most of these came out in 2018. Some of them, such as transit gateways and shared VPCs, very recently, as recent as late November. And so those are all things you might want to follow up on as you're kind of trying to figure out and plan your journey to the cloud. So tips and tricks, just some thoughts and reminders of certain things, right? So when you connect the resources outside of your VPC, it's often going to require you to get onto the AWS backbone. So keep in mind that you're going to need an IGW and an elastic IP or some kind of NAT. An elastic IP is a type of NAT to do that. So for example, I'd mentioned way at the very beginning, if I want to connect a VPC in Oregon to a VPC in Northern Virginia, and if I want that to all stay on Amazon's backbone, I'm going to have to deploy IGWs and get some kind of a NAT device in there and basically VPN between them or something like that. Of course, if I wanted to route that through my on-prem, I might use the VGWs and BGP or something. So it depends a little bit, but just be aware of that. You really want to kind of carefully consider how your applications are going to do their HA. So for example, you have these availability zones that provide great HA, but they are hard layer 3 boundaries. So if currently you do HA kind of in a layer 2 methodology, DCI or OTV or something in the Cisco world, you may need to rethink that a little bit or adapt it or something like that. So you need to kind of consider items like that. Again, a word of caution, don't think of items like the IGWs and BGWs as routers. Think of them as routing services. They might look like traditional routers, but looks can be deceiving. Be cognizant of the scalability limits in general in AWS. For example, the VPC routing table size that we mentioned. And then a quick word on cost. This actually came up when I was at the Cisco user group last week presenting on this. People were saying like, well, it's so expensive to go to Amazon. If you're going to go to Amazon, you either want to work with your internal people or work with maybe a consultant that knows a lot about Amazon, but you really want to make your apps a little more cloud friendly if you want to get the most bang for your buck in terms of moving things to the cloud. You want to consider things like pipelines and DevOps and so forth, and how you're going to do things like backups and storage and so forth. It can be very expensive in Amazon. That'll be doubly true, though, if you just try to take some legacy app as is and mimic it in the cloud without thinking about things like how am I going to do updates and deployments and so forth. So you really want to work with someone on that, either internally or externally, either way. Thank you very much, everyone. I appreciate your time. Thank you. Bye.